ladies and gentlemen, we're looking at 3.2 notes using parallel lines and transversals. Okay, this is really important. These 1, 2, 3, 4 things are really important. We're going to be using them a lot. I want you to have a picture, the definition, and the word down on your postulate and theorem sheet. It's going to really help you out. So let's make a picture. If two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So I'm going to give you an example. So I've got two parallel lines. If we can remember, ladies and gentlemen, you might want to write this down somewhere, that if two lines have these double arrows, it means they're parallel to each other. It's cut by a transversal. That's another line that's just on there. Okay. And then an example of corresponding, so these aren't all the corresponding angles for here, but these are an example of corresponding angles, would be like this is under the parallel line, and this is under the parallel line. They are congruent to each other. Okay. Does anybody know the difference between a postulate and a theorem? Postulate is a rule that's accepted, where a theorem, you can prove it, prove that it's true. Okay? So notice that, because I'm going to ask you this in your next quiz and on your test, which ones are postulates and which ones are theorems.
It only kind of makes sense because theorem and theory. Yeah.
That's a good point, Jeff. Theorem is theory. Okay, that's why we have to prove it. Okay, postulate, corresponding angle, postulate. Okay, next we've got alternate interior angles. So we've got two lines that are parallel, so I've got that double arrow thing again. My transversal. And alternate interior angles, this is just an example of one of them. Interior means in between. Alternate means kitty corner from. The other kitty corner from each other. Alternate interior angles. Okay. Alternate x, and that's a theorem, so we can prove that. Alternate exterior angles. We've got two, again, parallel lines, so there's double arrows again. Cut by a transversal. And what does exterior mean? Outside. So they'll be outside, and they'll be alternate kitty corner from each other. Okay. And that's a theorem, so we can prove it. Consecutive interior angles. So we've got two parallel lines cut by a transversal, and consecutive interior, so it's in the inside on the same side of that transversal. And those are supplementary. Supplementary means it adds up to 180. Okay, so all of them are congruent except for consecutive interior angles, and they are supplementary. Now, mathematicians, just like math teachers, are lazy people. We don't like to write a lot of things out. So all of these things, and we have horrible spelling, notoriously. So, me in particular. So I am going to abbreviate all of these. Instead of corresponding angle postulate, I'm going to put CAP. I'm going to put AIA for alternate interior angles. I'm going to put AEA for alternate exterior angles. And I'm going to put CIA for consecutive interior angles. Okay, so all of these should go on what sheet? You got a question? Or just get out of your way so you can write it down? Yeah. Okay, so this is a great time to be doing that right now while we're waiting for everybody else to write this down. Would be to write this on our postulates and theorem sheets. You can sketch these little things. Remember, there are pictures of these as well on the back on the word wall. They will be up for all the tests and quizzes as well. But the definition's what? This one goes with alternate exterior angles. Good question, Ryan. Remember the word wall on the back of the room? It's got the pictures on there and the words, but it doesn't have the definitions, so you still might want those. All right, ladies and gentlemen, we're going to move on. We're going to do our first proof today. It'll be fine. Trust me. I feel like the proofs actually for Chapter 3 are easier than the proofs for Chapter 1. In the middle of me recording this. You can't wait until we're done with notes?
No.
All right, Terry. Okay. So our first proof. So let's make sure we've got this picture down on our paper. I didn't make up this picture. This picture should have shown up on your notes, but it didn't copy very well. Okay?
So we got draw that?
Yes. Make sure you draw this. We have K is parallel to H, and we want to prove that angle 1 is congruent to angle 2. Can somebody tell me what the first line of this should be?
Given.
Given will be the reason. What's the statement? K is parallel to H. Are we remembering what is? Can you show me with your arms what the parallel symbol looks like this? What about perpendicular? Upside down T. Okay, so if I ever draw something like T is perpendicular to H, you know that's perpendicular. All right, let's look at this picture. We're trying to prove that alternate interior angles are congruent. But when you prove something, you can't use that in the proof, right? Jeff is on his phone. Like in a definition, we can't use that word in the definition to state what the definition is. We can't use the proof to prove what we're trying to prove. So let's look at the picture. Is there any angles up there that are congruent to each other, and how would you know? We can't use alternate interior angles, but what else is up there? 3 and 2 are vertical angles. Are there any others that are congruent to each other up there? So we can't use alternate interior angles. Is there any others? Are there alternate exterior angles up there? No. Consecutive interior? No. What else is left? I heard it. Corresponding. 1 is congruent to 3 by what? Corresponding angles. Okay, let's look at this, because we have all of our angles up here. We need 1 and 2 to be congruent. We have 3 is congruent to 2, and 1 is congruent to 3. What can I do? 1 is congruent to 3, and 3 is congruent to 2. What can I do here? How can I say 1 is congruent to 2? Actually, you could use substitution, but do you guys see that 3 and 3 match?
Yeah.
That means you could cross those out and make them equal to each other. It's like syllogism, or what's that other word that we use? Not symmetric. Transitive.
So wait, moving around for the
No.
Huh?
Substitution is also the right answer in this case, because I could take out 3 and put in 2. So if you have substitution, that would also be correct in this case. Okay, you are going to try the next proof on your own. You can't do the proof without copying down the picture. So we're proving that 1 is congruent to 2 again. This is alternate exterior angles, which means you can't use alternate exterior angles in it. I've given that M and M are parallel to each other. Notice where 1 and 2 are. Notice where 3 is. What can we do? It's yes, an M. It's an M and an N. Okay? Please, it's very similar to the last one. I'm giving you the next 3 minutes to try it on your own. 3 minutes. If you've tried it already, you can go ahead and keep writing your stuff down in your postulate and theorem sheet. Oh.
What's the next? Right.
Okay, let's keep going. Let's try this on our own. You can't have the first proof we ever do be on a quiz. Let's try it. It's very similar, if not exactly the same to the last. Say my name. Yes. No, this is what's going to prove. So 1 and 2 came each one last. You got 3 and 2. Good. What about 3 and 1? we wanted to. Because we're proving alternate exterior. So you can't use alternate exterior, but you can use alternate interior, consecutive interior, corresponding. You use vertical angle.
Any AIA?
Is that what you're
Anything
trying?
gotta be across from each other.
AIA. Anything in two classes?
All right. I'm hearing a lot of good things. So let's start writing this down. We know M is parallel to N by given. Can somebody tell me another thing that they see up here that we know they're congruent? What do we know is congruent, Maya? How do we know 3 is congruent to 2? 3 is congruent to 2 by vertical angles. Is there anything else we see up here that are congruent to each other? Anybody want to Kyle?
1 and 3.
By what?
Corresponding angle postulate.
CIP, cap. By cap.
Let's see.
Okay, and then we know angle. Go away. We know angle 1 is congruent to angle 2 by transitive. Or as Jeff says, substitution. Okay, let me ask you a question because proofs are funny. There are multiple ways to solve this proof. But let's talk about order. If I switch 2 and 3, would that make a difference?
Yeah.
No. What about if I switch 2 and 4? Would that make a difference? Yeah, you can't do it. What if I switch 3 and 4? Could I do that? No. Do you see why 4 has to come next? Because you have to, 4 has to come last because you have to have 3 is congruent to 2 and 1 is congruent to 3 to use transit. But it doesn't matter if vertical angles comes before corresponding angles because they don't affect each other. All right, we've got 3 more quick problems to do, and then we will move on to our writing and our homework. We've got A, B, and C. I know it's got D, E, and F, but we're only going to do A, B, and C. So please copy these down. We've got 2 parallel lines, and we've got x minus 8 in one corner and 55 in the other.
Except for B.
That's for A. For B, this shouldn't be here. Hold on. I've got, in this corner, 53. Inside these 2 lines, I've got 5x plus 2 for B. For C, I've got 10x minus 2 and 98. Yes. Okay. So has everybody got A written down at least?
Yeah.
All right, let's look at it. Are those 2 angles, what are those 2 angles? Alternate interior, alternate exterior, corresponding, or consecutive interior? Alternate exterior and alternate exterior angles are what to each other? Congruent or supplementary? Congruent. So we just say x minus A equals 55. Add 8 to both sides. Done. That's it. Okay, B is a trick. Because 53 and 5x plus 2, are they alternate interior, alternate exterior, corresponding, or consecutive interior? Yeah. They're nothing. They're nothing. That's why it's a trick. But let me ask you a question. See the lines in green?
Yeah.
Are they congruent to each other?
Yeah.
Because of what? They're what to each other? Vertical angles. So this would be a 53 right there, right?
Yeah.
And now what are 53 and 5x plus 2? They're what? Consecutive interior. And consecutive to interior angles are supplementary, so they add up to 180.